So in this problem, we're given that a is less than 0 and b and c are both positive. So on the number line, what this means is b is to the right of 0 and a is to the left. I'll start with a, and when I see inequality like this, I notice that there is a common term a on both sides. I'm going to factor that, and so we need to assess whether this is true or not. Now a is negative and b minus c is negative because b is less than c, so this product will be positive, so that holds true. So a is out. If I look at b, a squared less than b squared less than c squared. So here the key thing is that if a is far enough, meaning it's a negative number, but if it has a large magnitude, then if I square it, it may not be less than b squared and c squared. So for example, if a is minus 4, b is 1, and c is 2, this would be 16, which is not less than 1 squared, less than 2 squared. So the answer is B. So we don't have to technically do the remaining ones, but I'll do it for completeness here. This has to hold true because a cube is negative. Both b cube and c cube will be positive. And because b is less than c, that would still hold true. So again, c is out. Then for d, which is I think is the harder one of all of them, I'll do it in pieces. So we want to assess this. Again, I subtract. So all of these techniques that I'm using will be applicable to other problems as well. Inequalities that you might see on this exam. So b is positive. b minus a is also positive because b is to the right of a. And then finally, bc, we need to assess this. Again, I factor b. b is positive. Again, c minus b is positive because c is greater than b. So that also holds true. So d is out. And then finally, a squared b less than a squared c. Now here, I can divide both sides by a squared because I know for sure a squared is positive, and we are given this condition. So that also holds true, which means that's out. So the answer is, to recap, is B.